Okay, we can polish off problem set 20 here, or at least the sister problems to problem set 20. You have problem 94 yet to do, and I had originally planned just to do problem 93, but let's double up and let me do 92 and 93 from you. I wanted to do 92 because it's a little bit more instructive than just 93. You know, we looked a few problems ago at exponential problems, and the way we solved the problem that was given us was to make use of the fact that if a base a is raised to an exponent u, and it's equal to same base a raised to an exponent v, then it must be the case that u is equal to v, and you go ahead and solve that problem. You know, there's something similar with respect to logarithms. If the log base a of some quantity m is equal to the log base a of some quantity n, then m is equal to n. Let me make this an if-then statement. You know? And you can make use of that in this problem 93 if you'd like to, because it's certainly possible to write 2 as a log base 3. Let me do that over here. Log base 3 of 3x minus 2 is equal to 2. But let me write log base 3 as 3 squared. Because after all, that's 2 times log base 3 of 3. And the number that you put on 3 as an exponent to get 3 is 1. So this is 2. And now I'm in the form log of a, where a is 3, of m, let m be 3x minus 2, is equal to log of a, again, where a is 3, of n, where n is 3 squared. So it must be the case that m is equal to n, or 3x minus 2 is equal to 3 squared. Yeah, so that means that 3x minus 2 is equal to 9. Add 2 to both sides, and we get 3x is equal to 11. Divide both sides by 3, and we get x is equal to 11/3. So there's certainly one way to approach this problem. But probably the preferred way, the way that you're going to grow to learn to like to approach both of these problems, is just to make use of the inverse properties of the logarithm. The inverse of log base 3 is 3 to the x. So to do problem 92, the second way here, let's just raise both sides of this equation up as exponents on 3. Log base 3 of 3x minus 2 is equal to 2. Yeah, and now let's evaluate this left-hand side, because the log base 3 of 3x minus 2 is the exponent that you put on 3 to get 3x minus 2. So if we take the exponent that you put on 3 to get 3x minus 2 and raise it as an exponent on 3, you get 3x minus 2 is equal to 9. And once again, x is equal to 11/3. Okay, we're going to do problem 93 exactly the same way. Now we've got log base x of 4 is equal to 2. If I raise both sides up as exponents on x, didn't do that quite right. X raised to the 2, so the left-hand side is an exponent on x. The right-hand side is an exponent on x. And now you've got, you know, u to the v is equal to v to the u if you would. But another way, a to the v is equal to a to the u. But another way to solve, which unfortunately just gets you right back to this, the way to solve this is to make use of this fact that the log base x of 4 is the exponent that you put on x to get 4, and say, well, then this must be equal to 4. And if that's the case, x squared is equal to 4. That seems to say that x is equal to plus or minus 2. Okay, and that's not quite the end of that particular problem, because let's be careful. Let's always go back and make sure our answers look right. Does x equals 2 work here? Yeah, log base 2 of 4 is indeed 2. But how about minus 2? It doesn't work there. Minus 2 does not work when we check this. The log base negative 2 of 4 is not 2. So in fact, the answer here is just x is equal to 2. All right, off we go.